Hello and welcome everyone. My name is Peter Robinson and this is the Ethereum Engineering Group Meetup. Today we have Dr. Joanne Fuller, who is going to tell us about how to investigate and analyze an L2. Joanne, before you lead off on your slides, do you want to introduce yourself?
No worries. Thank you, Peter. So my name is Joanne. I worked in R&D at Consensus for 5 years, and I did a lot of looking at things through a formal verification perspective. Before that, I was a data scientist, many years as an academic, and a long time ago, I did a PhD in cryptography. But yes, thinking a lot about L2s recently, so that's why I'm here today.
Okay, awesome. Well, look, I'm really looking forward to your talk because I know that I'm going to learn a lot. So please lead off on your slides.
Okay, I'll just share screen. And okay, have they come up full screen?
Yes, they have. They look awesome.
Great, thank you. And I'll put my glasses on so I can see. Okay, so today I'm going to be talking about what we can learn about L2s from public data, and I'm using Phala as a case study. Now, I mentioned I was at Consensus for 5 years. I did get to spend some time looking at linear, a lot of time thinking about the arithmetization, and a little bit of time thinking about the Plonk verifier contract. But one of the things that I really wanted to do was to try and get some perspective on overall L2 systems, sort of the bigger picture. And I thought it would be an interesting learning task to pick one and to go through and just to sort of see what I could learn, not being in any particular company, but just see what I could learn from that type of perspective. So that's what I'm planning to do today. So to give you a bit of an idea, I'm very much approaching this from the perspective of, I'm just going to take you through, I suppose, how I went about this project and sort of the questions I asked myself and where I went to look for information. So I'll go through a little bit of motivation, some of those initial questions, and I've had a practice, so I'm hoping it will make sense. I don't know, I like to write hand notes when I learn things, but when I was doing this, I did try to sort of trace my progress through and keep track of the questions and the sort of screen captures of transactions and so forth, and links to various documents. So that's pretty much what I'm going to go through today in my presentation. So I see it very much as a sharing of learning. I'm certainly not a Phala expert. I have my areas of expertise, but I'm still learning about the sort of the broader L2 landscape. And I do want to give a disclaimer that I haven't actually spoken to anyone at Phala to confirm sort of my findings. So it is purely based today, what I'm talking about, on what I've been able to see and sort of my conclusions that I've drawn from that. And I'm not associated with any of the companies that I'm going to talk about. So it's a learning exercise. Hopefully what I've done will help others. I haven't really done this sort of work before. And so it was sort of a test for myself, and hopefully it can help others. Okay, so the first question was, why Phala? So I wanted to learn more about L2s. There's lots of really exciting things happening at the moment. There's a lot of talk about different types of zkEVMs and the choices people are making. And at the time, I was thinking about which L2 I wanted to research and learn a little bit more about. In January, of course, was the launch of Phala. And I've got a few screen captures here. So there was lots of hype, lots of great blog posts, really interesting things being said. Of course, I suppose the main thing is that it's achieving a type 1 zkEVM compatibility. And so that's, and you know, it's the first OP Succinct layer 2 on Ethereum. It's, you know, OP plus zk technology. So all those sorts of buzzwords. I felt like it was a really good candidate. And Phala itself, they've got, you know, they're doing stuff with AI. So I just thought that, yes, this would be something that would be a worthwhile candidate to learn more about L2s. Now, Okay, so the next thing I suppose I should mention is that when I started reading all of those blog posts, and I've got a few extra captures of some of the key sentences here and the sorts of words, I was seeing a lot about SP1. I saw mention of the OpStack, and of course a lot said about Succinct. So my question was, well, how did they do it? I mean, this is great, but how did they actually do it? And from my perspective, maybe hindsight's a really good thing. And now I sort of look back at these when I was putting the slides together, and I thought, well, yeah, they do kind of tell me what they were doing, but by the time I started reading this, I knew SP1 was involved, but I wasn't completely sure how it all came about. And my first sort of technical pursuit was to go and look at the Phala GitHub site, and I couldn't find any repositories that I could look at to sort of see what was happening with their L2, and so that meant going to Succinct, and I've just got a screen capture here to sort of I suppose sort of say when I first started looking at this, you know, the SP1 repo is pinned. It's talking about being a feature complete zkEVM for developers, and when you go into that, you start to and I have got it written down so I'm a bit more precise about what they say about it. You know, they say it's a performant open source zero knowledge virtual machine that verifies the execution of arbitrary Rust programs, and that's the key, arbitrary Rust programs. And so that all sounds very wonderful. I had a memory of an SP1 project that I had sort of come across previously, and I did put a little screen capture down the bottom. That was the SP1 Reth project. And so, I don't know, at this stage, I was reading a lot about SP1, and I was thinking, was that the path they went down? Was it like the SP1 Reth project that they used to then create Phala? I should note that when you go into the SP1 Reth repo, you see that it was archived last year, and that certainly sort of made me think, no, there's more happening. There is the OP Succinct repo, and of course that was the one I started to look at next, and that talks about turning any OpStack rollup into a full type 1 zkEVM rollup. So already I was getting a sort of I was still wanted to learn a little bit more about SP1. It was obviously going to be involved, but wasn't 100% sure how they did it. You know, this is Phala's new L2, but the OP Succinct framework is all about upgrading an existing OpStack. And maybe it's a little bit of a case of semantics, but I wondered if there was any documentation that would talk about you want to create a new L2, you know, at what point, you know, do you create your OpStack and then upgrade it immediately and then deploy, or, you know, do you run it a little bit and deploy and then upgrade? I just wasn't sure how it all worked, and I was really curious to know whether I could actually work it out from looking at documentation, transactions, and what was happening both with the with mainnet and looking at you know, Etherscan, as well as looking at the Phala Block Explorer. So that's sort of was the beginning. And as I said, I did, when putting these slides together, I've tried to sort of do it in a logical fashion. I reserve the right to sort of flick back if I need to, and hopefully it will make sense. But yeah, I just found the whole process really interesting to go from, okay, these are, you know, all the things we're saying about this new L2, what can we really see when we look into the details? Okay, so just to clarify, so that was, I mean, I was convinced pretty quickly that it wasn't just like SP1 Reth, that it was actually the OP framework, OP Succinct framework. And I've got a little screen capture here. I probably should have had it on the last slide, but that, I suppose, doubt as to how it all came about and the timing, it clearly talks about upgrading your OpStack rollup. And because Phala was new, it just, I don't know, it didn't quite, it wasn't sort of the natural conclusion that I came to when reading about things. So the questions I wanted to be able to answer, and I did try to be, because I wanted to sort of track what I did and see and be able to convince myself, I sort of wrote these down as I was tracing through. So could I see that it was created as an OpStack network and upgraded? If it was that way, was the upgrade immediately? Did it ever run as an OpStack network? Can I actually go back with the transactions on L1 and L2 and see what happened? And just how does it all work? And then what would we say about Phala in the end, given all this extra information? Okay, so then it was a case of collecting data. And I suppose I used to do a lot of teaching of statistics, and I feel like I had flashback to, you collect your data, you build your evidence, you come up with your conclusions. And I'm also hoping, I suppose, that this talk is a sort of a nice collection of resources to do this sort of thing, or to have a go at it. So on Conduit, you can get all sorts of information. They've got lots of details about Phala, and including, you can have a look at the contract addresses, the rollup config, and the Genesis file. And so that's always, I think, a really good place to start, just to sort of see what's there, and to compare it to the information that you can see about the current network. I mean, it's been running for a little while. I needed to use block explorers, quite like Etherscan. I did have a look at Block Scout, and I'll mention that a little bit later. I found something quite interesting just when I was tracing transactions. And we've got the Phala block explorer. And so that's really good to start to think about what's happening, particularly with the output routes. And the other resource that's really good, and certainly if I want to learn something about L2s, L2 beat is usually the place that I would have a look. Phala being new, it doesn't have all the sections that they do for some of their L2s, but they, and I don't think it's been upgraded yet, but certainly when I was looking, this diagram went up quite quickly to show the structure of the network, and they also had all of their current contract addresses. And I emphasize current because certainly at that stage, the addresses that I first saw there didn't match up to the ones that I was seeing in that network information from when it was created. Now, I suppose this area where I've highlighted is the area that is of particular interest in thinking about how the network was created. And certainly when you look at this diagram, we can see that there is an OP Succinct L2 output oracle. Now that contract is, I certainly knew by this stage of looking at the diagram that is indicative of it being based on the OP Succinct framework, that upgrade framework that I've mentioned. Now, a few other things to notice here. Certainly, if we're doing the zk rollups, we're going to be, I just lost my mouse, compared to a basic OpStack network, we see that with the Succinct framework, we're going to have this gateway that allows the proofs to be verified. So we need a verifier contract. The Phala it's quite an interesting setup. You can still have an optimistic mode. So we're still seeing some of the sorts of things with the challenger, but yes, I'll talk a little bit more about the verifier aspect towards the end. So this was all my sort of starting information. And I mentioned that I sort of immediately saw some differences between the contract addresses on L2 beat, the current contract addresses. And I did a little bit of a lot of them I looked them up with Etherscan, and I had a look at the contracts, and I sort of got a feel for that, yes, everything is correct. That is the current system. But when you go back to the actual network information, so the Genesis file and the original set of contract addresses, you can see that it is not an OP Succinct L2 output oracle. It is just the L2 output oracle, and that is indicative of it being an OpStack network. Okay, so I think I'll mention this slide again in a little bit, but I just wanted to, I suppose, hopefully take you on the journey with me of what I was looking at. It's lots of information, lots of data, but hopefully it's making sense. Okay, so at this point, I had seen the genesis and the roll-up file for Phala. I was pretty sure that it was an OpStack network and then upgraded, but having never sort of been through the process of actually spinning up a testnet, I thought I was going to give it a go. And just I wanted to try and work out the timing of the process and whether they would have sort of started the OpStack network, but not actually deployed it and upgraded it sort of before deployment, or whether they fully created the OpStack network and then upgraded. And I don't know, possibly I'm showing my ignorance to say that is a question that I had, but this was also a chance to learn a little bit more about the way OpStack works. And certainly I was reading a lot about the different components, and I had an idea of what OP Succinct was going to do in terms of changing it, but I thought it was really nice. So if anyone is working in blockchain and hasn't had a go at using the faucet to get their testnet ETH and actually going through this process, I highly recommend it. It felt really good to do something quite hands-on. So I still just followed a tutorial, and I should note that I've got a link in the slides. It does say that they're sort of not to rely on the tutorial, that it's being upgraded, but I was able to get everything to work. And I went through and I wanted to sort of see that sequence of, when you set up your OpGeth, when you set up your OP node, and how it all worked and where the upgrade might have happened. Now, I went through the process and I got to where I was able to get my L2 config files. And in particular, I was able to look at the Genesis file and the rollup file. And that was just really nice because although I could go and look at other OpStack-based networks and have a look at their files, I kind of wanted to be able to definitely sort of tick off the list that, yes, Phala looks like it was created this way. So I did that, and I actually stopped at this point. The next steps were to basically initialize and start OpGeth, then start OP node, and then the OP proposer would be the final step. And I was going to come back to it. I sort of didn't need to in the end. I may still as an exercise, because I think it would be quite fun to sort of have that network working and try some things out. But yeah, it got me to a point where I could see, okay, you could do these steps. And then I thought, well, I'll go back to the transactions and think about whether there's anything else that tells me the timing of what happened. Okay, and yeah, this is just a reminder. I think I've already mentioned this, but certainly from what I found on Conduit, the original output oracle contract was just the L2 output oracle. It was not the OP Succinct. So when you go in and look at the code, it's just the OpStack version. It's not the upgraded one. So my focus now was to say, well, did the upgrade happen before deployment? Did it happen after it had been running for a little while? And I was reasonably confident that I could go back and trace transactions, doing a lot of work with smart contract bytecode and thinking about, storage. I was keen to see it all working in real life. Okay, so this is now the what did I do? And I'm not going to click on any of the links as I do this. If you're interested, you can get the slides and you can have a look. Obviously, there was each time I looked up a block, there's lots of information and the transaction, but I was just thinking initially about sequencing, and so that's what I've put here. So I looked at, okay, our Phala L2 had Genesis at L1 block 21418000. When did we start seeing the contracts deployed? So the L2 output Oracle proxy was deployed at 8007, and then the actual L2 output Oracle contract was the following block. Now, one of the things that I was thinking I would be able to use to decide if it ran as an OpStack network or if it was instantly upgraded was to think about whether that original OpStack contract actually did anything. So were there any transactions? And I'm not, again, I'm probably showing my sort of newness to doing this type of thing. When I was looking at Etherscan, that contract didn't actually show any other transactions. It just showed it being created. So no internal transactions. But then on BlockScout, I actually found 2 internal transactions related to that contract, remembering that that's the OpStack version of the contract. And in particular, this second one, we will see that block number again very shortly. So I'm, to be honest, not 100% sure why I couldn't find those internal transactions on Etherscan. That's sort of still on my list of things to figure out, and some remaining questions. Okay, so then when did the OP Succinct version of this contract get deployed? So you can see by the block numbers, it's a little bit later. I've actually got some times on the next slide. So it was basically 2 days later. And in having that upgraded output Oracle contract, we obviously had to upgrade the proxy as well. So it would point to the new contract. And just because it's hard to look at block numbers and think about the gap between, I turn them into some more meaningful measurements, I think. So basically, we had the original OpStack version of the contract. 2 days later, the OP Succinct version was created, and about an hour and a half after that, the proxy was upgraded. So we had definitely 2 days where it was running as OP, as an OpStack network. Okay, so this is, I suppose, just a little bit extra. I was primarily focused on trying to think about the process of creation and confirming how the network was structured. But from looking at the L2 beat diagram and thinking about some of the other sort of components, I thought it was a good opportunity just to trace through those addresses, to think about had anything changed, were they all the sort of original contracts or end users, and I also wanted to start and to think a little bit about the blobs being sent, and tie that to the upgrade process. So and I did have the list from L2 beat of all the current addresses. So certainly, and you can see from, I've used the terminology of the diagram. So we've got the, I think that's, let's go back. Oh, okay, I'm not sure if you're seeing it. I got the little link showing up. I didn't mean to do that. So we've got the L1 sequencer account, and I had a look at when it was funded, and the first blob happened on the 16th of December, so last year, and then the second blob sort of, well, not quite an hour later. So I had a look at that and started thinking about, you know, the sequence of those transactions. I've included a few other notes here. Some of them are probably less relevant, but I was certainly thinking about whether addresses had changed, and certainly the user account that we're sending our blobs to, it's referred to the batch inbox address in the Genesis file, so that hadn't changed. And our L1 proposer, which I just moved my Zoom bar. So this account here, I had a look at when it was funded as well. I had a few extra questions sort of stemming from those, but I suppose that was just the initial work, just to think about when things started. Okay, and I also wanted to have a look at what was happening in terms of those output routes from L2 to L1. Now, this time I was using the Phala block explorer, so I certainly had a look at the first few L2 blocks, and you know, not a lot happening. That's probably a different story. I did go a little bit further with that and started to think about, you know, have a look at the L2 addresses and what contracts were deployed at the creation time of the network, but that's sort of a tangent that I won't go down. In terms of the initial output route, so you can get all that information quite easily from the Phala block explorer. And I had a look at the first one. So the first one, and I've sort of put some of the information here. It's not a screen capture. I do have a screen capture on the next slide. But I suppose the key thing I was looking at is what block number it happened in. I was looking at checking that the proposer matched up to the proposer that, you know, was the current proposer. And I was thinking about what contracts were involved. And I should just note that one of the things that I didn't really realize until I was doing this in more detail is that when I looked at this, it looked like it was actually sending the output routes to the OP Succinct L2 output oracle. But because the block explorer is just telling you the name that it currently points to, it wasn't actually sending it to that contract. It's just that the proxy currently points to that. And so when you look back, I thought that was a little misleading, and you just have to be careful. But certainly from the screen captures that I have, you can see that, in fact, the first output route was sent to the L2 output Oracle contract. So that was when it was OpStack network, and it was only for the second output route that we were sending it to the upgraded Oracle. And looking at the internal transactions, it became quite obvious at this point, because you could see that all of a sudden we were actually using that SP1 verifier gateway and getting down to the actual verifier contract. So I thought that was quite interesting. It was a good lesson for me as well, just to not necessarily jump to quick conclusions when tracing the data. And yeah, I found it quite interesting to be able to go in and see a bit more detail. For a lot of these, just because I was interested and trying to learn, I went in and you know, looked at more of the log information, state variables being changed, all that type of thing. Okay, so I know it's a lot of information, and hopefully it's making some sense in that we're at a point where, okay, so we know, we're pretty sure that it was created as an OpStack, it was upgraded. It looks like from the transactions that it was running in its OpStack form for the first blob and the first few blobs, and the first output route was actually processed under the OpStack system. Then it was upgraded and it's sort of running as we see it now, with a few little tweaks, which I'll get to. So some of the other questions, I suppose I felt like I was on a bit of a roll looking up and tracing what happened and when. So I was interested in the L1 proposer account. Did they perform any other transactions before that first output route? Was there anything, you know, is it still all happening the way that I think it should? And my answer to that question was no. So I was able to go in and confirm that. So the first transaction for the L1 proposer was actually that output route transaction that I showed. My apologies for switching screens, but this one here. So that was the first one. So that was what I was sort of hoping, because if it was different to that, it would have been, you know, something else, some variation that I hadn't considered. Another question, has there been only one L1 proposer? And the answer is yes. So I went back and I suppose I included this. It doesn't really add too much to the how it all happened story, but it's a nice example, I think, of I was actually able to go in and find where the address was added. So initially it was set to the 0 address, and then it was changed to that L1 proposer account, and I was able to find the block and the transaction hash where that happened. And I should, the other thing I'd say here that I haven't talked about today, and certainly if you have a look at the L2 beat pages, they also have a lot of, not just the contract addresses, they have a lot of information about the multi-sigs and those sorts of aspects. And certainly while I was tracking transactions, I started to see some things that I recognized from their list. And so that's another aspect that's, I think, quite interesting to think about who has control and if anything changes. Okay, so what else can we learn? I suppose we're at a point where I feel like hopefully I've convinced you that you can use the public data to investigate how a network like Phala was created and to confirm ideas about how the sequence of how things happened. But I was also interested to start to think a little bit more about the zk stuff involved, and with the and that meant thinking about that SP1 verifier contract that I'd seen. And I'm just, oh, I should have gone back the other way. My apologies for flicking. I'm just going to, just this little bit in here, which we know is new from the OP Succinct upgrade. Wanted to think a little bit more about that. And so it seemed quite a nice idea to actually sort of probe the OP Succinct L2 output Oracle contract and to find out, you know, what contracts it was using. And so that's what I've got here. So I went through and I was able to find out, so there's some keys involved, or a commitment and an aggregation key, and I was able to check that contract. I just read those values and I was able to see what they currently are. I was able to get the current owner. I was able to confirm the proposer, and I was able to get the address of the actual verifier contract, which, as I said, I was interested to do a little bit more about the zk stuff. And so, and I was interested to see whether there'd only been one verifier contract, if it had been changed, and so forth. So, okay, now I will say a little bit more about the verifiers, but I think that this is a good spot just to try and package it up, what I found. And as I said, possibly in hindsight, I could go back to those original blogs and say, yes, maybe it was more obvious, but at this stage, all those transactions, lots of screen captures, I had some little timelines drawn on paper. I was pretty happy that I understood how it had all happened. So again, lots of links in my files if anyone's interested in reading more or trying this out, but pretty much OP Succinct, what does it do? It enables you to upgrade an OpStack network. So it enables the blocks to be proven with SP1 through a lightweight. So this is just the quote from their words are better than mine. A lightweight upgrade to OP Proposer and an on-chain contract that tracks valid L2 state roots. So it's not a huge change to the OpStack framework. And I think I included this diagram again just to remind you that you're not changing OpGeth or OpNode or OpBatcher. It's just an upgrade to OP Proposer plus the switching out of that L2 Oracle contract. So that's what we're looking at. A bit more detail, and again, this is probably beyond the sort of the point of this talk and taking you through what you can learn from looking at all those transactions and files. But I think it's quite interesting, and hopefully this will also sort of serve as a base for anyone who wants to learn more about sort of the next level of detail for Phala and any future roll-ups that are created in this way. So OP Succinct, as soon as you start looking at their documentation, you learn about the 4 components to its system. So there's a range program, And that's where we're batching our blocks and generating the proofs. The aggregation program then takes several of the range proofs and bundles them so that we can reduce our on-chain verification costs. And ultimately, we're going to be putting them in a wrapper that's either Groth16 or Plonk for on-chain, and Phala uses the Groth16 system. We've got that OP Succinct L2 output Oracle contract. So it's just a modified version of what OpStack has. It stores an array of the L2 state outputs, and it's modified to verify the zk proofs. So we see that in the diagram. We saw that there's a gateway that then leads into the SP1 verifier. And the other component is the OP Succinct proposer. So that's an upgrade to the original OP proposer that fits in with this process. And I mean, there's no point in me sort of just reading it out to you, but as a basic summary, the OP Sync proposer, it's quite interesting to look at the code. I have been through large quantities of the code because I was sort of keen to see a bit more detail, and there's a lot of sort of paths to go down, but there's two containers, so they sort of split things up. And probably the other important thing just to note is that there is a succinct prover network. So the proofs are that's where the proofs are created, and sort of so that part is managed for a network wanting to use the system. Now I've got in my little sort of extra summary box. So we had the OpStack network. We've upgrading. There's the two steps: the new contract, and then the upgrade of OP proposer. And certainly for Phala, we know when step 1 was performed precisely. We can go back and look at the blocks. Step 2, and this is, I do have to update my slides. I had a typo that I corrected just before. I previously said before, but step 2 was performed after this particular block. We don't know exactly when the upgrade, but this is the block where the output route was part of the sort of OpStack system, and then the next output route was processed under the OP Succinct framework. So the step 2 happened somewhere in between there, and that's as precise as I can be. Now, I've got a few last slides in here, and I've got that sort of reminder back to those initial blogs that I was seeing that use lots of lovely buzzwords and tell you all the sort of the key information and the benefits. When I was starting to look, I suppose I was looking for a little bit more detail, and what I've done here is I've tried to put that detail into the slides. Now, this is sort of using the same format that L2Beat uses for a lot of its L2s. This isn't currently available for Phala on their site. And so I've tried to sort of put together what I think it might look like, you know, when we get that level of detail appearing for Phala. So created as an OpStack network, upgraded. I've got some links to all the different software we're using for the roll-up node. Because of the way it's created, all of a sudden we can say a lot more. We know what kind of compression scheme it uses. We've got the Genesis file. We know the data format. And again, it's not my diagram. It's from the documents. But all of a sudden, all these things, I felt like they started to make a lot more sense. Just initially when I was reading, because I had that doubt as to how the network created, I didn't feel like I really could draw conclusions about these sorts of things, but in getting to that point, it's sort of nice to put it all together. So another category that you see on the L2Beat summaries, state validation. Now, this could be a whole talk in itself, I think, and it's quite interesting. So I thought it was worth mentioning, even if I don't go into all the detail. But so with this type of network, what we need to do is that we need to have each update to the system state being accompanied by a zk proof to ensure that the new state was derived correctly. And that, of course, is that we've applied the valid user transactions to the previous state. And that's what we're ultimately checking in our smart contract, even though we've got lots of layers of sort of compression and wrapping. Now, how does it work here? Because that's really, I suppose, the clever part of the system. So they use Kona. So when you go into the range program within the OP Succinct repo, you can see that they're using Kona to implement the state transition function. And so that's a Rust program. I went and did a little bit of reading about when that was first released, and I feel it's valid to say that, that was an important step, being able to have a program like Kona as part of OpStack. So using Kona and SP1, the zero knowledge proofs can be generated, and that's how we get that upgrade. I've included a little bit here. As I said, I don't want to go into a huge amount of detail. This is really just as a reference to try and tie everything together. I think it would need a very detailed talk in itself to go into any more detail, but the proposed architecture, I've got again, this is from their documents, but just to try and take some of those. We know there's a range program, we know there's an aggregation program. So just to sort of think about that and the steps and how we're taking our blocks, and the range program is generating the proofs for the batches of transactions. You can see here, I mentioned that there is this synced prover network that takes care of the proof generation. And so that's featured in this diagram. And basically, we're aggregating those range proofs to be able to ultimately do our proof on chain. So there's the aggregation step, and then there's also then a final Groth16 wrapper. There's lots of information that goes into the actual upgrade to OP Proposer and how that works. There's 2 services, and it's quite interesting to look at what each of those does. And again, it's not something I've looked at before, but I've spent some time tracing through all of that code. And yeah, this is, if you're wanting to learn more, which I suppose is the point of my talk today, I think it's good to just not take these sorts of conclusions or summaries for granted, but to actually go in and see if you can see it happening in the code, because ultimately that's what's running. Now, I did want to just finish with a little bit more about the zk stuff, and in particular SP1. And at the end, I do have a link to both the SP1 white paper and the Succinct white paper. Now, with SP1, because I had that initial sort of thought as, was everything done just with SP1? I spent a bit of time going through that repository. There are lots of great tutorials. I did the Fibonacci one, and they actually then show you how to do just a general aggregation proof. So remembering SP1 is all about taking programs, an arbitrary program written in Rust, and creating the proof system. So when you look at the OP Succinct framework, you can go into their repository. You can actually look at the Rust code for the range and aggregation programs, and then you can go back into the SP1 repository and you can see the sort of the generic aggregation program, which I think is quite nice as a contrast. And sort of the basic pipeline, you have your Rust program, you're going to generate this sort of ELF file, and then all the mechanics take place and you end up with your Stark proof. So it is a Stark-based system, they say. And again, I'm just quoting from the documentation. I wanted to start to, I suppose, build up a little bit of a picture of how they put everything together. Some of that you can see by going into the code and linking to various repositories, but they've built it using Plonky 3. There's all the information about what arithmetization they use and the polynomial commitment scheme. And so, yeah, this is, I possibly didn't need to include some of this, but just I've tried to capture. This is all from the documentation. It's not my own summary, and the images are from the documentation, but just if you're trying to get a quick summary of the important parts. So, if we the execution trace, quite often we're going to have to shard it because it becomes very large. There's all sorts of really interesting things about sort of the different options you have, constant size proofs, the wrappers, and certainly if you spend some time looking at the SP1 tutorials, you'll see that if you're going to have an aggregation component, you need to make sure that you're, in this case, like the range program, that you have constant size proofs so that then they can be fed into the aggregation program. So and then probably the final diagram is the most important aspect. So you end up with your proof, you're going to wrap it and ultimately wrap it in Groth16, and they use NARC to do that. Now, I should say that I was quite keen to have a look at the details of that, and I've sort of managed to manipulate the code to sort of go in and find the files where they're using NARC, and there's some very big files of all the constraints that get created. Remember, in the end, what we're doing here is we're verifying the SP1 verifier. So that means creating a constraint system and going through that process. And I didn't get any further than that. I feel like I could just spend maybe not even days, it might be weeks just going through all the code, but I certainly sort of got hints or a feel for how it all works. And again, I'd encourage people to not just accept what's written, but to go in and to test out and see if you can actually see it working. And just some final notes. I think I mentioned before, I'm quite interested in the zk aspects. And in terms of the verifier, I felt like this was maybe the most sort of realistic target for just doing some extra checking in a short amount of time. Now, back in the diagram, we know that the output oracle via this gateway, it sends the proof to the verifier contract. And one of the things that I quickly realized is that these addresses that I'm seeing for Phala, they're just the standard ones for SP1. So if you look at the SP1 documentation, even if you're not doing an L2, if you're just doing a more basic zk system, so like when they have the Fibonacci example, you could set that up, and they give you this list of contracts for the gateways and for the provers. And basically, as soon as I saw that this is the gateway that Phala is using, that is the one that SP1 says to use if you want to do a Groth16 proof system. And so they maintain those. Now, I was, one of the questions I had was, has Phala only used the one verifier contract? So again, with my questions of has something changed, I think it's interesting to ask those sorts of questions. And tracing back, in fact, the gateway, there was an initial Groth16 verifier contract, so an earlier version that was frozen. And I found the block where the current verifier contract that's used by Phala was added, and I was able to go in and see that the other one was frozen as well. So that was quite interesting. Now, I know from looking at the L2B page that another question people have is to say, well, you know, what are verifiers doing and where do the keys come from and what can we confirm? Now, I had seen and they were in one of my previous slides, there was a range verification key commitment that came from that range program, and then an aggregation verification key. And they go into the ultimate proof as public inputs. And I wanted to see if I could get them, because one of the things I noticed when I was first experimenting with the sort of latest versions of all the repositories is that the keys I was seeing didn't match to these, and I thought they should. So I went back through the sort of the previous commits, and I should have written a script. I was very close, but then I came across the one that I needed to get the right keys. So yeah, I was actually able to go back and sort of the bit of a summary of the process here and the particular checkout that I had to use, and I was able to get those keys myself. I didn't get to do any more than that with them, but it was kind of nice to feel like I had got to that point where I could replicate what had happened. And the question would be, as another level would be to say, well, could I do something like similar to that I've seen on L2 Beat for a different L2 where they were able to actually go in and get the Groth 16 keys. Now, I didn't have time to do that. I started to dig into all the information, but I think that is definitely a task for another day. But again, I've included it here just because I thought it's as a learning sharing exercise. You know, the more of these sorts of things that we try and we test out, you know, it's good for sort of not only learning and sharing, but also just thinking about the security and what people are saying about these systems and verifying it. Okay, I have no idea how long I've spoken for and whether or not I should have paused and asked if there are any questions, but I just wanted to make sure that I feel like it's I had this sort of fragile sequence of what I did in my head, and I was hoping to get it across. But yeah, my conclusion from all of this is that you can learn a lot, and it's actually as someone who hadn't done a lot of sort of hands-on blockchain work, a lot of formal verification, a lot of thinking about interesting topics, but not as much sort of, you know, spinning up test nets and deploying contracts. It was really nice to do that, and I felt like I learned a lot, and I still have some questions that I'll go back to and I'll keep learning, but it was really nice to actually, we talk a lot about being able to see what happens on the blockchain. It was nice to test out if I could see what was happening. And yeah, again, just lots of great tutorials. Try them out. There's nothing to lose. I've probably filled up my laptop with a lot of stuff that I'll need to have a bit of a tidy up. But it's a really great exercise. And yeah, hopefully what I've done will help others that just want to experiment. I had trouble finding, I think, I can't remember now if it was the SP1 or the Succinct. One of them was a bit tricky to find, the white paper, so I've included the links, and all through my slides, if you get a copy, there's lots of links to block explorers, documents, and yeah, hopefully this will be a resource. So that's me. I hope I didn't talk too fast or waffle too much. Yeah, I'll pass.
That was really good. So thank you very much. So shall we throw it to questions?
Yep, that's fine. I don't have a question slide, but
yeah, this will do. Are there any questions? So I have two.
Okay.
But so do you think it's possible to deploy Succinct's SP1 contracts and just go from nothing to OpStack with the zk from the moment you turn the chain on? Is that possible?
I think it is. I haven't, I mean, I didn't go that far as to try it out, but I can't think of any reason why you wouldn't be able to. I may be shy, and well, I don't know. Do you have any? Do you think it's possible? But I feel like it should have been able to be upgraded from the beginning. So I was a little surprised when I saw that first output route, but go to the original contract. But yeah, I'm not. I can't think of any reason off the top of my head why it shouldn't have been possible.
Yeah. Okay. All right. Well, that's good to know, because I don't know the answer to that question. You know, whether there's some requirement that there's that first output route before you upgrade.
And I will just add, if I can, the fact that that's how it happened, that they actually let it run as an OpStack and then upgrade, that did make me wonder, have I missed something? So yeah, I mean, if anyone watches and knows that why it was done that way, I'd be very interested to know.
And Harathia has turned his video on, which is fateful and probably means he's got a very good question, or even better, knows the answer.
I was going to say, do you know the answer to that?
No, it's just a question.
Okay, go ahead.
So regarding at the beginning you mentioned that the SP1, well, There was a project that seemed to be a root of what is being used here and was discontinued. So what exactly is the connection there? Was that just used in an independent way since it's open source, or is it the same people continuing the project, or?
Another good question. I'm not 100%. So from what I could see, there was the SP1 Reth project, which was basically creating the type 1 zkEVM using Reth, doing it just that. So my feeling would be that maybe that helped inspire the OP Succinct framework, but that was clearly archived. I can't remember which month last year, but I feel like maybe it was August, September. So it feels like they decided not to continue with that and then focused on the OP Succinct framework rather than the sort of the pure, I'll call it the pure SP1. Yeah, so I'm guessing that there was a reason. And I mean, I think from what I've seen of the OP Sync framework, it's quite nice. So yeah, I'm imagining that it just was more beneficial to go that way.
But do you know if there is a connection in the people? If it's the same? I mean,
oh yeah, that's all. I mean, yeah, SP1 is Succinct Labs. Yeah, all the same people. I don't know if that's it. I haven't looked to see who was contributing to the code, but yeah, all the same company.
Okay.
Yeah, and I remember seeing this as well at some point a few months or some months ago, but I can't remember. I think we worked out the relationship, but I can't remember what it is. Yeah, and I'm not sure if Zhen Yang was in those conversations and remembers.
Okay.
Who's on the call. But
in while we wait, I have another. Well, okay.
you go ahead with your question, I think.
But
Yeah,
he unmuted for a moment, so I don't know if he's going to talk.
Sorry, what's the question again?
You're on mute, Peter.
Narathu, you tell it.
So Peter was wondering whether you, Chen Yang, remember about conversations about the connection between or what the SP1 Reth people were doing, if I remember correctly.
All right, yeah. No, unfortunately, no.
Yeah,
Sorry.
Okay. Some months ago, and I think that was mainly Serge and I were looking at something. Yeah, don't worry. All right, well, I've got another question. Or have you got another question, Horacio?
Yeah, I wanted to ask, so that Reth project that got archived, do you know if it has been used in other projects, if it's only being used in SP1?
Again, I mean, don't quote me because I'm just going on, but from what my searching and what I saw, I think it was really just an experimental project. I'm assuming that it fed into what they did, but yes, I'm not, I don't know. I mean, theoretically, you should be able to use SP1 for sort of a really large program. It's set up to be an arbitrary Rust program, and there are things in place for when it gets really big. I don't know if there's sort of practical limitations. I think that would need a lot more experimentation, and well, they would be in a better position to comment on that. But yeah, that's beyond my expertise at this stage. But yeah, interesting. I mean, yeah, I wish if only there were, 50 hours in every day, and I could. It's a lot of fun. I can't emphasize that enough. I'm repeating myself, but yeah, just trying stuff out. It's I feel like you could do it for everyone involved in L2s. It'd be nice to test out the code and look through it, but not enough hours in life.
Yeah, Joanne, I'll set up a call and you can chat with Uma, who's the CEO or CTO of Succinct.
Okay.
Ask her quiz questions. But my question was, so I noticed that the Phala were using the 3.00 prover system, and then they upgraded to 4.00 release candidate 3. You know, and the reason why they have release candidates is they're not, you know, they're waiting for it to be stable enough to make it, yeah, so rather 3.00 to 4.00 release candidate 3. So I haven't been keeping a close eye out, but I think 4.0's come out. And I don't know, the idea of using something that's a release candidate in a production system seems curious. And I don't know, I'm not sure if I've got a question here, but did you look at that and go, really?
Yeah, no, well, that's, I was in just, and I mean, I spent a lot of, when I was looking to try and get the range key commitment and the aggregation key, and sort of looking at all the commitments and sort of the comments, and yeah, I don't know. I suppose I'm just going to agree in that I was curious. I didn't come up with an answer. And I didn't, one of the things still on my list to do was to actually just look at the contract and see if just a simple comparison would sort of tell me much, but there's obviously more happening in the background. But yeah, I don't know. It seemed like a very short amount of time. And yeah, I was a bit curious about that, but I suppose I don't have the avenues to find out a definitive answer.
Yeah, okay. Are there any other questions? Okay, let's go to the next slides. Okay, the merch store is still open. Woo! Right, next slide. Okay, so in 2 weeks' time, Jana is going to talk about visualization of transactions and trying to analyze anomalies. And then Ermias is going to be talking about the data availability landscape. And a little bit later than usual, we're going to have a talk on peer DAS. So this is a new part of the Ethereum protocol that's emerging, which is going to allow better scaling of the blobs. And another really interesting thing that's coming over the horizon is a talk on 3-slot finality. So rather than having to wait 2 epochs, maybe just have 3 slots. So that would give us something like, what, 30, 40 seconds finality on Ethereum, which would be much, much better than about 15 minutes. So very exciting and interesting talks coming over the horizon. Next slide, please. Okay, so if you're here today and you missed a bit or aren't going to be able to see all the talks or want to see the past talks, go to YouTube. And if you think, I really want to throw stones at and ask tricky questions of people, please attend live, join the meetup. There's a Slack workspace, which can be very interesting to have interesting conversations with people. And sometimes there is example code, which is in that repo. So you've got one last time right now to ask tricky questions of Joanne. Well, looks like Sandra's got one in chat. What does she say? Oh, my chat's way over there. All right. What an excellent talk. Okay. All right. Not a tricky question at all.
There shouldn't be tricky questions when it's just a learning exercise. We're all learning together.
Yeah, we are all learning together. So true. So very true. Well, thank you very much for agreeing to do this talk, Joanne. That was really insightful. And I will put you in contact with the SP1 people, because I think you've done enough that, yeah, I think you deserve the answers to the burning questions. Yeah,
that would be lovely. Yeah, I really, it's one thing to see what you can learn from what's publicly available, but yeah, it would be nice to get a glimpse on the other side.
Yeah, for sure. All right. Well, thank you very much, everyone, and have a great day. Bye-bye.